Hello, and welcome to Math with Asna. In this lesson, we're going to continue our work with triangles, and we're going to discuss CPCTC. Now, CPCTC is an acronym. We'll discuss what it stands for in just a second, and then we'll practice applying it in proofs. CPCTC stands for Corresponding Parts of Congruent Triangles are Congruent. Basically, what this tells us is if I have two congruent triangles, let's say triangle ABC is congruent to triangle DEF, then I can make statements about the sides and the angles. For triangles, if I have congruent triangles, that means I have 3 pairs of congruent sides and 3 pairs of congruent angles. So AB would be congruent to DE. AC would be congruent to DF. Angle B would be congruent to angle E. I can take a proof that specifies congruent triangles and then add on an additional statement to make a conclusion about one of the pairs of sides or one of the pairs of angles. Let's do an example of how this actually works in a proof. We've got our figure on the left-hand side. Angle B and D are right angles, so right away I'm going to put in those right angle markers. AB is congruent to CD. I'm going to put in my tick marks. I've already written out my given statement. So now from here, I want to think about how I can get to my proof. The thing that I'm trying to prove is that BC is congruent to AD. There isn't really a way for me to get there right now, but what I can do is prove that these two triangles are congruent. If I know that those two triangles are congruent, then I know that the parts are congruent. I have a lot of different ways to prove that triangles are congruent, but the fact that I have right angles here is a pretty good indication that I'm going to need to use HL. That's most likely what it's going to be because I've got those right angles there. So I'm going to see if I can make HL work. For HL, I need a hypotenuse and I need a leg. Notice that I already have DC and AB that are congruent. That's the leg. So that's already checked off. I need to prove the hypotenuse. This hypotenuse is shared between both of those triangles. AC is shared between both of those triangles, which means that it's congruent to itself. So my next statement can be AC is congruent, and I could say AC or I can say CA, it's the same thing. It's congruent to itself, that is by the reflexive property. And I had to write that down because I needed to make it very clear in my proof that this is the leg and this is the hypotenuse. So I've shown that I have the hypotenuse congruent. I've shown that I have the legs congruent. That's all I need for HL, which means my next step can be to jump to the triangles. Triangle ADC is congruent to triangle CBA. That is by HL. This is where CPCTC comes in. I've shown that the triangles are congruent. After I've done this, once you have a statement in your proof that says these triangles are congruent, you are allowed to use CPCTC to show a different congruence statement from your diagram. So I want to prove that BC is congruent to AD. Well, since I know that the triangles are congruent, I can say that these sides are congruent. So my next step and my last step would be to say BC is congruent to AD. How do I know that's true? That's true because of CPCTC. Corresponding parts of congruent triangles are congruent. Let's try another one. We've got 2 sets of parallel lines. We also know that G is the midpoint of RS. I'm going to go ahead and put in my parallel line markers to start. I'm not going to do anything for that midpoint yet because I haven't actually made a congruent statement, so I'm going to hold off on that. Now what I'm going to do is go through each of my givens and I'm going to see what statements I can make. I don't have a right angle here, so I'm not going to be using HL. It's going to be one of the others. If I'm looking at these parallel lines tell me something about angles. And I've got two sets of parallel lines, which means I'm going to get two angle pairs. Midpoint tells me something about sides. So that will give me a side, two angle pairs and a side. Think about the ways that you can prove triangle congruence with two angles and a side. I can do AAS or I can do ASA. So these are what I'm going to be using. I'll figure out which one it is as I work through my proof, but for now I'm just going to kind of keep it in the back of my mind that I'm going to use one of those. Let's start off with RD and GH. RD and GH. If those are parallel, that tells me that angle R and angle HGS are congruent. Now, they're not the only pair that's congruent, but they are the pair that's still inside the triangle. And since I'm trying to prove that the triangles are congruent, I want to keep the angles inside the triangle. So angle R is congruent to angle HGS. Those are corresponding angles. Okay, so that is done. This one matches up with step 2. Let's see if we can get this one. DG is parallel to HS. If DG is parallel to HS, that tells me that angle DGR is congruent to angle S. That's going to be my next one. Angle DGR is congruent to angle S. And again, that is corresponding angles postulate. Okay. Only one left to do now is my midpoint. So let's see. G is the midpoint of RS. That tells me that these are congruent. RG is congruent to GS, right? Midpoint tells you that a side is cut in half. This is the definition of midpoint. Now look what I've got. I have an angle, then a side, then an angle. These triangles are congruent by angle, side, angle. So I'm going to go ahead and write that as my next step. Triangle DRG is congruent to triangle HGS by angle, side, angle. All right, I'm almost done. Now I have to take that extra step to show that this is also true. DG is congruent to HS. Since these are sides of those triangles, and I just proved that the triangles are congruent, I can say that these are congruent by CPCTC. So overall, in order to use CPCTC, you're going to go through the exact same steps that you did when you were trying to prove that triangles are congruent. You'll go through that, you'll prove that the triangles are congruent, but then you'll take that extra step and say, if these triangles are congruent, then this other thing is also true. So CPCTC is just one more step on top of your normal triangle proofs. If you learned something, please like and subscribe, and stay tuned for more videos.